Hey everybody, welcome back to the channel. I'm Evan, co-founder of Hello Interview and a former Meta staff engineer. And in this series, we've been breaking down common system design interview questions together. And today we got a new one for you. So today we're going to work through designing Facebook Live comments. Of course, this isn't limited to Facebook. It's any live streaming platform, but the live comments feature, so the comments that come in under the video. This is actually the second most popular question asked in Meta system design interviews. And it's really popular across all of the major FAANGs, so it's a good one to know. If you like this content and you want more, of course, I'm obligated to say it. Please like and subscribe. It really helps us, and the increasing number of subscribers is really motivating for us to continue to make these videos. Stefan and I want to make a lot more of these in 2025, particularly in the beginning of the year. So subscribe. You'll get the notification when those come out. If videos aren't your thing, head over to hellointerview.com. I have a written guide for this exact problem that you can read through. There's also dozens of others on the site. We also have Guided Practice, which is a tool that allows you to try this problem and about 20 others. You get to draw on the whiteboard. You get personalized feedback as you go. Candidates really, really love it, so check it out. And there's tons of other free content on hellointerview.com that's going to help you prepare for interviews, including, maybe most importantly, mock interviews with senior plus engineers or managers from your target company, people just like me who are going to sit down for an hour with you and kind of let you know where your gaps are and give you everything you need to know to make sure that you're successful in your interview. So without further ado, let's get into it. So as always, before we jump into the actual design, let's take a moment to go over the roadmap or the framework that we're going to use throughout this video. And it's the framework that I recommend that you use in your real system design interviews. And so if you've watched any of our other videos, you've seen me do this 100 times, you're tired of it, feel free to fast forward. But for anybody who's new, we're going to go through these 6 steps. First off, we're going to outline the requirements of the system. And so this is your opportunity to ensure that you are on the same page with your interviewer about the system that you're going to build. This includes what we call the functional requirements, or the core features of the system, as well as the non-functional requirements, or the qualities of the system. After that, we're going to outline a very basic list of core entities. And so this can be thought of the nouns of your system. Oftentimes this correlates almost one-to-one with the tables in your database, but we're going to stop short of outlining the full data schema or modeling any relationships, the justification being that we just don't know it yet. It's too early in our design. But we do want to outline the nouns because they're going to give us the context necessary to understand our API and then move into our high-level design. And so once we have those core entities down, as I said, we go into the API. This is where we'll outline the core user-facing APIs, and we'll exchange those core entities that we outlined in step 2. Now from here, data flow, this is for infrastructure-heavy system design interviews. You'll need to decide on the fly whether or not it applies. In this case, it won't. And so we're going to jump right into step 5, which is the high-level design. The high-level design is when we head over to the whiteboard, we start drawing boxes and arrows in order to outline a very simple system where the goal is to satisfy our core functional requirements. So in this case, we're not going to satisfy the non-functional yet. Our system might not be able to scale. It might not be low latency. It's very basic, but it's the minimum required system in order to satisfy those core functional requirements. So we'll get that down, and then we'll move on to step 6, the deep dives. And so this is where things get interesting. This is where senior and particularly staff candidates show their worth. And this is where we're going to go one by one through those non-functional requirements that we outline in order to expand upon our design, our original high-level design, in order to make sure that we satisfy the non-functional requirements. So this is where we'll handle the scaling, the latency concerns, security concerns, anything like that that comes up. So that's the outline that we're going to follow. Let's do that now. Before we jump into our first step, which will be the functional requirements, let's just take a really brief moment to at a high level explain what FB Live comments are. So you're probably familiar with Facebook Live. Facebook Live is a feature within the Facebook app which allows users to live stream videos to their audiences. Now, what we're going to be designing is what happens under that live stream. And this is going to be the comments that get streamed in real time. So as users are watching a video, they can be posting comments and reacting to the video as it's happening. Those comments get streamed to all other users, as I said, in near real time. And so, of course, this is not exclusive to Facebook. This is true of TikTok Live. This is true of Instagram Live. This is true of Twitch, YouTube Live, any streaming platform. So the solution that we're going to have here applies to any of those. Awesome. Okay, so let's get started with our functional requirements. As I had mentioned, the functional requirements are the core features of the system. This is where you're going to agree with your interviewer on what you are designing. Now in our case, our core features are relatively straightforward. I'm going to paste them in because it's going to be better than you guys watching me struggle through typing here in the live video. But the core functional requirements of Facebook Live comments are first, most obviously, users or viewers need to be able to post a comment. That's crucial. Fantastic. The second is that viewers can see all comments posted in near real time. And so as new comments are coming in, we're appending those comments to the bottom of the list or the log so that users can see them, importantly, without having to refresh their page or anything. And then third is that you should be able to see all the comments that were posted before you joined. And so maybe in the case of Facebook Live, TikTok Live, this means that you can scroll up on your feed of comments and it'll load older comments that you can still view. So those are going to be our core functional requirements. Now I put some things below the line here. These are things that would be reasonable in an interview like this, but are going to be out of scope for us. That's the ability to reply to comments and the ability to react to comments or even just react to the video in general. And so one thing to note about this below the line thing, don't feel obligated to do this in your interview. My suggestion would be to use this technique of below the line or out of scope only if you're in the process of brainstorming and something comes to you that you discuss out loud and then agree with the interviewer that it's out of scope. So if you're thinking and brainstorming about the functional requirements and you say something to the interviewer like, well, should users be able to reply to other comments? And they say, no, let's consider that out of scope. Then that's something that you can specify is below the line. Basically a contract between you and your interviewer of these are the things that I'm going to focus on. These things are not. Next up are those non-functional requirements. And so non-functional requirements are statements about the system's qualities that are important to the user. And so they can be phrased like the system should be able to, or the system should be statements. So for example, if you were designing something like Twitter, it's like the system should be highly available, prioritizing availability over consistency. The system should be able to scale to XYZ, right? Some things you want to talk about here, CAP theorem, scalability, latency, durability, security, fault tolerance, compliance. These are all the things you want to consider. But crucially, you don't want to just list those out. The reality is that most systems nowadays need to do all those things. But what you're doing in your non-functional requirements is calling out to your interviewer the set of qualities that are uniquely relevant and interesting to this problem and the things that you're going to prioritize when discussing the interview. So let me paste in a list here of non-functional requirements that we can discuss. So for non-functional requirements, here are some things I want us to discuss. So first off is scale. At this point in the interview, I would ask my interviewer, what's the scale that we're talking about here? Now, they might ask you to estimate it, or they might tell you. Oftentimes when I'm the interviewer, I'll just tell you here. And in this case, we want to scale to millions of concurrent videos and up to thousands of comments per second per video. So this is going to be a lot. This is going to be huge scale. Actually, there's a fun fact here that I think I put in the write-up, and that's that the most popular Facebook Live video was called Chewbacca's Mom, funnily enough, and it featured a mom thoroughly enjoying some plastic, Chewbacca mask. And it had been viewed over 180 million times. And so that's tons of concurrent viewers. We can estimate some portion of them were commenters, and that would get us to these thousands of comments per second, no problem. And so the second thing that we're going to consider here is CAP theorem. We've considered scale. Now we're going to consider CAP theorem. Now CAP theorem you want to consider in almost any system design interview. I'd go as far as to say any system design interview. And the question here is, do we prioritize availability or consistency? And so the way to think about this, and we have a video specifically on this trade-off, but do you need strong consistency? But in that another way is, does every single write or does every single read of your system need to be reading the latest write? And so in the case of our comment creation, does everybody need to see the latest comment immediately when it comes in? And the answer is clearly no. Like, we want real-time, low latency broadcasting. That's what we'll get to next. But it's not an error if that doesn't happen, right? We would rather be highly available. We'd rather you get comments than see no comments just because we can't show you the very latest comment. Hopefully that makes sense. And so in our system, we're going to prioritize availability over consistency as it pertains to creating comments and thus reading those comments. And then the third thing we want to consider here is around latency. And so we do, despite our eventual consistency, want to be as quick as possible to broadcast new comments to users. Right? It wouldn't make too much sense if you're watching a World Cup broadcast, Messi scores a goal, and then 5 minutes later, people are commenting, oh, Messi, what a goal, right? You want to see those comments come in almost immediately. And so we're going to actually quantify this, and we're going to shoot for about 200 milliseconds. Another fun fact, 200 milliseconds is what we as humans perceive to be real time. And so if you're in an interview that needs real time, 200 milliseconds is what you're striving for. Anything lower than that, frankly, it doesn't matter. Humans won't perceive the difference anyway. And so last thing that I'll say about these non-functional requirements is that aim to quantify them where possible, like we did here, and always put them in the context of the system. So availability greater than consistency, meh, not that interesting. But for comment creation, okay, I understand why. Same, just low latency, meh, of course, but what specifically? In our case, comment broadcasting, and then we quantify it. Same comment about out of scope or below the line. Security and integrity are two things that are often important to live comments, making sure people aren't saying bad things. It's not something that we're going to focus on in this particular interview. Zooming back out, we can see our next steps are to define the core entities and then the API. So we can do that now. The reality is that these two parts of the interview should move pretty quickly. And particularly in this interview, they're not overly interesting or difficult, and so we should be able to get them down pretty quickly. Let's start with those core entities. Let me zoom in to make this as easy as possible on you guys. What are the core entities of the system? What are the nouns of the system? What are the tables that we're going to have? These are all ways to think about this. Well, most importantly, we're going to have comments, certainly. We're also going to have a live video. Now, the actual data model for the live video, where it's stored, this is out of scope. This is another team that will handle this. But it's important to recognize as an entity because we're going to have relations to it. So I'll write it down anyway. And then we're, of course, going to have a user or a viewer. So those are our core entities. And we can then move on to our API and use those core entities to shorthand our API a little bit. So when you get to the API, the easiest step-by-step formula here is to just go back to your functional requirements and go one by one through your functional requirements, making sure that you have an API to satisfy each of these. Now, this isn't 100% foolproof. For non-user-facing system design interviews, something like a designer web crawler, this doesn't make as much sense. But if it's a product, if it's a user-facing product, as live comments is, then this is a nearly foolproof way to do this. And so some functional requirements may require more than one endpoint, but the process remains the same. Go one by one through your requirements and create the endpoints necessary for each. So the first thing is viewers can post a comment. Okay, great. We're going to use a REST endpoint, and we need viewers to post a comment. So what could that endpoint look like? Well, it's going to be a post because we're creating a new resource. What is our resource name? It's comments. Some of you have picked on me in the comments, ironically, for not pluralizing my resource names. So the reality is, to me as an interviewer and to most people, like, who cares? But proper RESTful semantics say to pluralize your resource name, so I've done that here for you. And then we need to know which live video we're posting this on. And so I'm going to use a path parameter here and pass in the live video ID. Now, why not put this in the body? Well, you absolutely could, but given that it is required, you cannot possibly create a comment without a live video ID. It's common here to put it in the path parameters, and so that's what I've done here. Now, what does this return? It can either return the comment or 200. What's the body? Well, the body is the comment itself. And notice how I'm not getting caught up in the details of, like, what is a comment at this point. Of course, a comment is going to need to have some content. If there were extensions here, then maybe it would have media attachments, which we're not going to handle. But I'm just abstracting this for now. And it's just a comment. It's the core entity that we've defined as a comment, is what is the post body there. So we checked off one of those functional requirements. Let's go back up and look at what our next one is. Viewers can see all comments posted in near real time. So astute viewers are thinking to themselves, wait a minute, this is going to be a WebSocket or some persistent connection. You're right. And if you know that this early in the interview, go ahead and write it down. That's fantastic. I'm going to take the approach of assuming that we don't know that, or even if we do, we're just going to build things up simply. And so the simple way to do this would be that we're just going to have some get endpoint. We're going to have some get get comments endpoint, sheesh, this is why I don't type in front of you guys like this, get comments endpoint, which takes in again that live video ID. And maybe it's just going to take in a cursor. So this is basic cursor-based pagination. And we'll be able to pass in the last comment ID that we saw, and this is going to return to us any new comments that have come in since that last comment with some page size here, maybe like 50, okay? And so if you don't know about cursor-based pagination, fairly straightforward. You're just gonna pass in a cursor, which is the ID of something in your database, some row in your database, and then we're going to get everything after that. And so that's what we're doing here. We're gonna get the 50 comments after this. And so we can just be calling this over and over again in order to simulate some sort of real time. We'll talk about that more in the high level design. And of course, this is not the optimal solution. It's not efficient. We'll do something better. But at the early phases of your interview, even if you are a staff candidate or something, it's okay to put this down for now. And you can just acknowledge, this is going to expand. This is probably going to use some bidirectional communication or unidirectional communication, but something persistent later on. And so the next one, viewers can see all comments posted before they joined. Well, this is essentially the same thing, right? We want to get all the comments for a live video, but instead of anything after the live comment ID, we want it before the live comment ID. And similarly, we want a page size, like maybe we want the 50 before this point in time. And then if we want 50 more, then our last comment ID would be updated to the last of that 50 that we just got, and we'll get the next 50. You kind of see how that's happening recursively. But the difference here is there's a direction. In one case, we're going past comments, and in another, we're going future comments. And so what we could do is we could just add that direction pretty simply to our API endpoint. Do we want after, or do we want before? That's a way that we can model that. So there you go. 2 basic REST endpoints, one to post a comment, the other 2 to get comments. I'm using basic query parameters here, denoted by the question mark for the first variable, and then the and sign for the remaining variables. Posts, gets, all pretty straightforward thus far. So zooming back out, we've done our requirements, our core entities, and our API. This is kind of the general setup of the problem. At this point, we've agreed with our interviewer what we need to do. We've set our parameters, our foundation. We know the general APIs that users are going to use to interface with our product. And now we need to move on to that high-level design. This is where things get fun, they get interesting. We start actually drawing those boxes on the whiteboard. And so just like with the API, with the high-level design, we are going to just satisfy our functional requirements. And we can do that by going one by one through our APIs. And so if we go one by one through our APIs, we'll subsequently be going one by one through our functional requirements. And we're essentially saying when this request is made, what happens in our system? What happens in the back end of our system? And what components are necessary in order to effectively fulfill that request? And so I'm going to move a little bit quickly through this high-level design. The reality is the high-level design for this system is really straightforward. And I want us to have adequate time to go into deep on the things that are interesting via deep dives. But let's talk about what it might look like. So the first thing is that users want to be able to post a comment. We have an API for that, a post comments to a live video ID. Cool, let's model that. What's that going to look like for us? Well, the first thing is that you're going to have a client. I'm going to introduce an API gateway. It's not strictly necessary here. It's a single client-server database relationship you'll find. So we don't need routing, but I'm going to take advantage of the middleware and I'm going to introduce it. I'm also going to have a comment service. And so this comment service is going to be responsible for comment CRUD operations. Let me just move it down a little bit. And then I need some way to persist these comments. And so there is my comments DB. Great. And so what's going to happen is the user is going to make that post request in order to create a new comment. Our API gateway is going to forward that onto our comment service. Our comment service is going to craft and then initiate a query to our comments DB in order to create that new comment. And so we talked about earlier in our core entities how we weren't going to talk about the data model or the schema just yet. Now is the time where we do it. When we get into our high-level design, you can see how it's really linear at this point. I've just told my interviewer this is going to save a comment. And naturally, now I can say, well, what is a comment, right? A comment's going to have some comment ID. That's going to be important. It's going to have the video ID that this comment was placed on. It's going to have the author ID. And then it's going to have the contents of the comment, the text of the comment, probably some created at field is going to be necessary. And so in terms of our query pattern, we're going to be querying by video ID a lot. So we'll want an index on that. We're also going to be sorting by the created at column, so that'll be important as well. And I'm not going to make any decision about the type of database yet. In your interview, it could go either way. You could talk about it now, that would be totally fine. I'm going to choose to talk about it when we talk about scale, because I think it's going to be more interesting. The reality is, for a simple high-level design here, any database is going to work. A SQL database is fine here, MySQL, Postgres, etc. Key value stores, document stores, they're all going to get the job done. So I'll go into more detail on that a little bit later. But important to know where your indexes would be, what your primary keys would be, of course, comment ID in this case. So that's the thing for us to handle. But very simple, client initiates a request, we save that comment in the database, and we return with our 200. Check. We now have viewers can post comments. It's a simple CRUD service. Next up is that viewers can see all comments posted in near real time. Now, of course, as we alluded to earlier, this is going to require some persistent connection. You'd be wise to let your interviewer know that. Hey, I know that this is going to require some persistent connection, but let me start with the simplest thing that we could do. The simplest thing that we could do is that basic polling with that API that we outlined here. So get comments for a live video ID that have happened since some given last comment ID that we have. This could also be a time, right? There's different ways to handle this. Time might even be more natural for this direction of the query anyway. But in any case, what we can do is then just have a simple client that is going to every 2 to 5 seconds query our gateway to ask our comment service if there are any new comments since a given comment ID. If no comment ID is given, well, then there's no comments since that point, right? That query is simple. That query is simple regardless of what database you chose. So if it was a SQL database, this is simply, select all comments, where video ID equals the given video ID, and created at is greater than the created at time of the cursor. Fine. And then similar query if this is a document store or key value store. This query is pretty straightforward regardless of what database you choose. So if you chose a SQL database, then it's just select all comments where the video ID is the given video ID and the created at time is greater than the created at time of the cursor or the last read comment. Nothing to it. Similarly easy on a document store or similar. Awesome. So again, we're just expanding this basic CRUD service. We can create things, we can read things, nothing to it. We're going to use polling in order to just get new comments every couple seconds, and those will be maybe not quite the near real time we're looking for yet. Again, persistence, connections will be important later, but it's a good start for now. The next thing that we needed to do is viewers can see all comments posted before they joined. And so we have the same API endpoint, we just specified a direction, and it's the same concept here. So when a user first joins the live video, they have no comments, they have no past comments, or they have no kind of new comments yet. We're going to probably first load up that live video alongside the last 50 comments or so from the video. And in order to do this, we'll use that same API endpoint. We're just going to switch the direction. In our query, that's just going to switch the greater than or equal to on the created at sign. So now we want the last 50 comments that are less than the current comment. And obviously, we're not going to necessarily have a current comment right out of the gate. And so if that's the case, we'll just start from the end of all existing comments, right? Similar concept there. Now, one thing that I'll note just for fun, but this wouldn't necessarily be the most important thing in this interview, but there's different ways to handle this concept of a user continuing to scroll up. So you've probably done this on Instagram or on Facebook Live, whatever it may be, where you scroll up and it fetches the last 50 and you keep scrolling up. And you want to just scroll up and up and up and up and up. Maybe you want to go all the way to the beginning. For whatever reason, you continue to scroll up and read comments. And there's different ways to optimize this. One really popular thing to do with pagination is to introduce a cache. And this is going to be a cache for a specific user ID, and in our case, live video, or just video ID. So that would be the key. And then it's going to be the comments as a list here. And so when a user fetches comments, past comments, we might show them the last 50, but we're going to cache the last 1,000. This is going to have a really tight TTL. And so maybe it just has a TTL of 5 minutes, because that's what we anticipate being the narrow window with which they might still be scrolling up. And so now if they scroll up above that 50, instead of having to issue the query, we can just go grab it from their cache and give them the next 50. Now, what you might be thinking is that why don't we just give them more than 50? Well, we can do that as well, of course. We can give them thousands and then let the client just show them the ones that matter at that point. There's different optimizations here. And this really would only matter for super popular videos where comments are coming in like crazy and somebody may want to be scrolling up really quick in order to fetch the next group of thousands of comments or so. Another pattern that we could do, again, just because it's interesting and related to pagination here, not specific only to this problem, is that we can have it be such that we send the client over maybe the 500 last comments, and then once the user scrolls up to about the 400th, then the client is going to know, let me go optimistically fetch the next 500 because I have a feeling they might finish this list, right? Finish this stack. Something similar to what we do in Tinder, if you've read that breakdown or seen that video. So I'm not going to include this because it's not the focal point here. In Design FB Live comments, if anything, I would just briefly comment on that, but I wouldn't let myself get distracted because despite how simple this high-level design is, and it is quite simple, basic CRUD service, it satisfies all of our main functional requirements, and it's left me plenty of time in the interview now to talk about the things that are going to be interesting, which are going to be these non-functional requirements around how to scale and how to ensure this low latency and eventual consistency. All right, with the high-level design behind us, it's time for everybody's favorite part, which is the deep dives. And so again, in the deep dives, we're just going to go one by one through our non-functional requirements and expand on this simple high-level design in order to make sure that we met all of these requirements. At the end, we're going to be able to look back and say, okay, I met all my functional requirements, I met all my non-functional requirements, I aced this interview, give me the offer, and life's good, right? So that's our goal here. So first off, one thing that I want to mention is the level to which you're proactive in the deep dives is a function of your seniority. And so if you're a junior or mid-level candidate, this might actually shift now to where you're less leading the interview and it's more of a question answering. So the interviewer might be asking you questions. You know, this polling approach isn't going to give us the low latency requirements we're looking for. What else could you do, right? For example. But if you're senior, especially if you're staff, the expectation is that you identify where the issues are and you drive the conversation towards these things. And again, the best way that you can do this is just by going one by one through those non-functional requirements. So let's do that now. I'm actually going to go in reverse order here, maybe. I'm going to start with low latency comment broadcasting. So this is the case where a new comment came in, it should show up on everybody's client quickly. As you remember, we're using polling right now. So we just have the client every 2 to 5 seconds asking if there are any more comments. Of course, this means that our latency is 2 to 5 seconds, as opposed to the 200 milliseconds that we were looking for. So we're going to want to find a way to speed that up. The key insight is that instead of using HTTP request responses here, where the client is saying, are there any new comments? And the comment service is responding after querying the database, we need some sort of a persistent connection here. So we need a way that we don't have to ask every single time, but instead the comment service can just tell us as soon as a new comment comes around. And so there's two popular technologies to handle this persistent connection. The first is WebSockets, and the second is SSE. And so let's talk a little bit about each of them. I'm actually going to paste in some notes here, again, to prevent you guys from watching me struggle while typing. Starting with WebSockets, WebSockets are bidirectional. And so you create a connection like this, and now at any point, the client can say something to the comment service, but the comment service can also say anything to the client at any point. This is great. And so in our use case, you can imagine a new comment gets created or saved by somebody else, and we just push over that WebSocket, right? So push instead of pull back to the client to say there's a new comment, and we can do this quickly. So this is great, and it's a viable option. But WebSockets also have some downsides. So WebSockets use their own protocol. They're not over HTTP or HTTPS. And this just means that they're a little heavier weight. What happens is that they initiate an HTTP handshake first, then they need to upgrade to a WebSocket connection, and you need to have all of your infra in between all of these places support this upgrade. And so for example, the client's going to go to the API gateway, try to do a handshake, establish a WebSocket connection here, right? And then likewise, it's going to go create a WebSocket connection here so that it can sort of be a pass-through. But in the case where you have load balancers, proxies, firewalls, or any of these things that don't support WebSockets, things are going to break. And this happens more than you would expect, actually. So oftentimes, if you're putting WebSockets into production, things are working in your test environment, everything's great, you put it into prod, and you realize that either it's not working at all or it's not working for some users. And this might be because some users are behind a corporate firewall, that's not going to allow for these WebSocket persistent connections. It could be that you have some production API gateway or otherwise, which isn't going to support them. And so there are plenty of API gateways that support it out of the box. AWS managed API gateway is an example. I think like Nginx has configurations for it, right? So this is by no means a task that cannot be achieved, but it comes with overhead and it's a bit more complex. And the main kind of interesting bit here, and maybe I'll write this down. Oh, I already have it there, right? So WebSocket's perfect for when it's bidirectional. There are as many reads as there are writes. So the client needs to get as many things as it needs to send or post. And so in the case of a messaging app, this was the last video we did. Check that one out with Stefan. We did WhatsApp, if you haven't seen it already. But in the case of a messenger app, this is perfect because there's likely a pretty close relationship between the amount of messages you're sending and the amount of messages you're receiving. But that's not the case here with live comments. The overwhelming majority of our users are going to be in a live video, watching the live video, and then the comments are just streaming in. Like the average here might be 1 to 1,000 or so. You can have some users who are active commenters, but the majority are passive. They're just watching. And so it's not bidirectional. We can still post a comment periodically with our RESTful API that we have with this, /comments post request that was right here on this HTTPS endpoint. But we can receive comments via that persistent connection. And so WebSockets seem to be a little bit of overkill. So what else can we do? The other thing that we have is, that pasted up here, SSE, or this stands for Server Sent Events. Sent Events. And this is actually perfect for our use case in live comments because it's similar to WebSockets in that it opens up this persistent connection, but it's unidirectional. And so in this case, it's just the case that the comment service can push changes to the client, but the client can't say anything to the comment service over this. And so instead of having its own protocol like WebSockets do, it's just over HTTP and HTTPS. And so it uses HTTP headers in order to specify that, hey, I'm going to be sending this over chunks, so keep this open. And it basically just looks like a long-running HTTP request. The other nice thing about this is that it doesn't require anything too fancy. Like browsers have built-in support to handle the reconnections and everything that go on here if for some reason you were to get disconnected. And so it makes it much more lightweight, and then given that we only need unidirectional communication, it's the right choice for us. Of course, you can still post a comment. You're just going to post the comment over the HTTP request response via our post endpoint, which was this guy up here. All right, so hopefully that all makes sense. Now, not all API gateways similarly support SSE out of the box. So there are still challenges here. Many of them will close your connection after a predefined period of time, and you need to go in there and update their configurations in order to elongate that or specify different headers to make it clear to the gateway that it shouldn't sever the connection after, say, 30 seconds or 60 seconds. So by adding SSE, it doesn't solve all of your infrastructural challenges, but it definitely makes things easier, lightweight, and we get the unidirectional communication that we're looking for. So let's tie that together. I'm going to just, by way of abstraction, draw a line through here. Technically, as you saw, it was to the API gateway and then the API gateway forwarding to the comment service. But I'm going to choose SSE. And I would say as much in my interview, I would weigh the trade-offs between WebSockets and SSE as we just did, and I would come to the conclusion that SSE is best. And so when a client now creates a comment, we are then going to look for all other users who are listening or watching that live video, and we're going to push over SSE that new comment so that they get it. And so you may be thinking, okay, but once a new comment comes in, how does the comment service know which users to push this to? Do we need to update our database? Do we need to store this state somewhere? And it's a great question, but it's actually really straightforward. And so all we need to do is have an in-memory mapping in this comment service. And so a new SSE connection is established. The first thing that can happen when this connection is established is that we're letting it know, maybe via the headers, which live video we're watching. And so we're saying this SSE connection is associated with video ID 1. And we can just store that mapping in memory. So here's an example of what that could look like. So these connections, these are just pointers to the respective connections. And now if a new comment comes in for video ID 1, I'll look in that mapping in memory and say, who all is connected to video 1? Oh, well, I have SSE connection 1, 4, and 7. So let me send it to them. And I can just do a for loop and do something like connection 1.send that new comment that came in. And then it's going to show up to the client for them to be able to render as needed. So this is how we're going to enable that sub 200 millisecond latency, because a new request is going to come in. Our comment service is then over SSE going to maintain this persistent connection that it can just push over that new comment. But you might notice that this doesn't scale very well. What happens when we need to horizontally scale our comment service? And now we have multiple of these, and it might be the case that a new comment comes in and it lands on this server, but the people who are watching this live video are on a completely different server. And so this one doesn't have SSE connections, right? It needs to somehow communicate with this one to send it over to them. And so that's one of the things that we'll talk about next as we get into scaling. So before we get there, we're going to look back at our non-functional requirements. We just talked about low latency, and now we're going to jump around and we're going to talk about scale. And so let's come back. We had talked about what that issue is. If the comment service horizontally scales, then we don't know which user is connected to which service and which live video they're watching. And so we don't know how to forward that on to them. So let's break this up a little bit. I'm going to move some things around. I'll keep them on the whiteboard so you guys have them later. But the first thing I'm going to do is I'm going to do a little bit of math now. And you might have noticed I didn't do math up front. This seems kind of like a faux pas. System design interview, you're supposed to do math up front. I disagree. I find that most candidates do math for the sake of doing math. They do some estimates on scale, some bandwidth. They look at me, they go, so it's like pretty big. And then they go design the same system they were going to design. That's not useful. Math is very important though, but math should inform your decisions. And so my concrete suggestion to you is to do math in your interview at the point where you have a decision that you need to make. And so in this case, the decision that I want to make is scaling here. And so I want to think about my bottlenecks. We said that we were going to have 1 million, so 1, 2, 3, 1, 2, 3. We said that we were going to have 1 million active live streams at any given moment. And then we would have like 1,000 viewers, we said, right? And so what I'm trying to figure out is how many SSE connections am I going to have at any given moment? Because an SSE connection is probably going to be my limiting factor here. Boxes, high-powered boxes, they can handle, give or take, like 1 million SSE connections. And so we'll use that as a rough number. And then our division becomes easy here because we have 1 million concurrent videos, 1,000 viewers of each. And so that means that we're going to need 1,000 services in order to handle just the number of SSE connections. And so we don't probably need 1,000 services when it comes to writing posts because the amount of memory that we have here, the network needed to write to the database, we'll scale this out later. It would turn out that that's probably less. And so this is our limiting factor. And so what I'm going to do right away actually is I'm going to do the following. I'm going to separate out a separate service. And I'm going to call this like the real-time comment service. And what's going to happen is that this service is still going to be responsible for what it was before of this HTTP post request in order to get old comments, post request in order to create comments, and the get request to get old comments. But instead, we're going to create the SSE connections to this guy. And so let me model that in a way that looks a little bit easier. Maybe. Can I make that transparent? There you go. So obviously this is going to be horizontally scaled too. But what I'm trying to get across here is that there are 1,000 of these servers, right? And I separated them so that I can scale them horizontally differently. And so I might only need 100 of these, but 1,000 of these. And that's why I've separated them out, right? So every time an SSE connection gets established, a user started watching a live video, we are going to connect them to one of these real-time comment services. And now you can see the issue, hopefully. A new comment just came in. Our comment service got that comment and saved it to our database. And now it needs to tell every single one of these 1,000. Let's say, to make this concrete, let's say that new comment for video 1 just came in. And so it needs to tell every one of these comment services, these real-time comment services, that is connected over SSE to somebody who is watching video 1 that it got a new comment. And so somehow we need an arrow here, and it would be a unidirectional arrow, right? So somehow we need to tell one of these servers. But how do we know which server? That's the big question that comes up. And so there's 2 ways to handle this. Let me show you the first here. And the first would be that you would introduce a central dispatcher, is maybe the way to think about this. And so you'd have something for coordination. Zookeeper is a great technology to handle this coordination. And so Zookeeper is going to keep a mapping, a registration of where all of these servers live and the live videos that they're responsible for, okay? And so then what's gonna happen is that when a new client wants to connect over SSE here, it's going to make a request either to our comment service or a real-time comment service, either way, and we're gonna go over to Zookeeper and say, hey, a new person needs to connect. They're watching live video 1. Which real-time comment service should I subscribe them to? And it's gonna give us a host IP address that we should end up connecting them to so that we can establish this SSE connection. And so let me show you here what that might look like. I'll put this over here, maybe even I'll make it a different color. Right? So that's what exists here in Zookeeper. It's this active mapping of all of the different servers and the videos that they're subscribed to and maybe how many users they have from each of those respectively. And so now the process would be that when a new comment comes in, the comment service, let me go back to black, the comment service is going to ask Zookeeper, hey, I have a video for live video 123. Which server should I message that to? And it's going to tell you, oh, it's this server. So all good. And then we're going to come down here. We're going to draw an arrow to these guys. We're going to let them know that we have a new message or a new comment that came in, and they can push it over to their friends over SSE, again via that in-memory mapping. And so really quickly, what actually happens here is that we don't ask Zookeeper every time. That's slow. We have a cache. And so in memory on the comment service, we've cached this mapping, this JSON blob. So when a new comment service comes up, it asks Zookeeper, the source of truth, hey, what's the registration? What's the mapping? Let me cache that on my server. And then I'm going to subscribe to any updates. And so any updates to Zookeeper are going to get pushed now. And my comment service is going to accept that incoming update and update its cache respectively. But tying this together, comment comes in, comment service says, either by looking in its cache or asking Zookeeper directly, I had a new comment for live video 1. Which servers have SSE connections to everybody viewing live video 1? It's going to tell me. It might be 1, it might be multiple. I'm then going to make a request to that server with the comment. And then that comment is going to look up in its in-memory mapping which connections it has for that live video. And it's going to push them over SSE. Of course, this should be unidirectional as well. Over SSE to the client so that the client can render that new live comment. So that's option 1. That's the central dispatcher approach. There's some downsides to this approach. The first and most obvious one is that we have an extra hop here. Every time that we come in, we need to ask Zookeeper. And so we largely got rid of that hop here, but we didn't on the connection. When a new thing is connected, it needs to ask Zookeeper, which should I connect to? And so again, the cache is helping us a lot here, but there are some potential downsides there. I'm going to hold my hands up and say, this is hand wavy. Honestly, the cache is probably fine, but you have an extra component to manage, potentially an extra hop here. More importantly is that there's complexity in handling changes to the real-time comment services. So these are going to go up and down respectively. They might die for some reason. We might need to scale horizontally and add more. And Zookeeper needs to maintain visibility of all of that state. And so when new servers come up, they have to be registered within Zookeeper. Zookeeper needs to be pinging heartbeats to each of these to know who is still up and who isn't. And so it's not just that these servers need to know who they're connected to, or at least the number of people they're connected to, but that needs to remain consistent with what Zookeeper sees. And so we've introduced a little bit of a consistency issue here that has the potential or capability to get out of sync. And so Zookeeper has a lot of great tooling to make this problem not much of a problem, but these are the potential downsides here. So that's that approach. Let me copy this and show you what the other of the two approaches would be. So alternatively, we don't have Zookeeper. Instead of having a single source of truth that we go ask, like an all-knowing oracle, hey, where should I send this to? Instead, what we can do is we can just broadcast. So think about the comment service just like yelling out into the ether, maybe with a megaphone. It just says, hey, I just got a new comment for live video 1. And then all of these real-time comment services have their ears open, their ears to the street, if you will, and they're listening. And if they hear, oh, live video 1, I have live video 1, then they'll take that new comment and they'll do something with it. And if they hear it and they're like, oh, I don't have live video 1, I don't care about that, they won't do anything with it, all right? And so in this case, we would introduce PubSub, which is perfect for this sort of broadcasting and subscribing. And so the comment service is going to get a new comment, it's going to, those arrows are the wrong way. That's getting annoying. It's going to put that new comment on PubSub probably after committing to the database. So first, for durability's sake, commit that new comment to the database, then broadcast it via PubSub. So put it on PubSub. This is just a channel, right? It's just like a message bus that we're going to put this on. And then all of these guys, all three of them, and when in production, all up to 1,000 of them or more are subscribed to this message bus, right? They're subscribed to this PubSub. They are subscribers. So this is the publisher, these are the subscribers. And so a new video comes in, it's going to yell via PubSub, new video came in, and then all of these are listening, and only those that hear one for which they know that they have an active user who is connected is going to take it, and then again, run that connection1.send with that new comment, right? So that's the PubSub approach. The nice thing here is that you don't have a consistency issue anymore, and because you don't have two things that need to know their own state. These real-time comment services are the only thing that need to know their state, and it makes failures in the real-time comment service a lot more graceful. You can imagine that one of these goes down, well then those users just lost their SSE connection. No big deal, right? And so they're going to need to reconnect. They're going to reconnect to a different one of these. We probably pulled another one up as well, but they're going to reconnect to a different one of these. The in-memory mapping is going to be updated. And then because we're still going over PubSub, we're just still subscribed, we're listening, and we're going to send it over to them. So these guys know what they need to care about, basically. There's no other thing that needs to be in the picture. So between these two options, there is no right or wrong answer. Both of these options are great. I tend to think that this PubSub solution is a little bit simpler. I think actually that FB Live comments in production went with, they don't use Zookeeper to my knowledge, but went with a single dispatcher approach. It's actually for slightly different reasons around scaling and co-location, which we probably won't get into in this video, but both of these approaches are absolutely valid. In an interview, if you're a mid-level candidate, you're probably not going to get into this much detail. If you're a mid-level candidate, you'll say, I'm going to use PubSub to broadcast from the comment service to a real-time comment service, which is connected over SSE or WebSocket, and you're golden. If you're senior, it would make sense for you to weigh these trade-offs a little bit. And then certainly if you're staff, you should be able to articulate the pros and cons of each of these, go into details about them. And then even furthermore, as we'll do here in just a moment, talk about how each of these may scale respectively. So now the problem that's worth discussing briefly, and this would probably just be something that a staff or a really great senior candidate talked about, would be that all of our real-time comment services are subscribed to every single new comment right now. And so you can look at this as like drinking through a fire hose. This is a pretty CPU intensive task now, because every single comment that comes in, they're checking in their mapping, they're determining if it's right for them, if it is, they're sending. But there's a lot of wasted resources here, because the overwhelming majority of the time, it's not going to be a comment that is something that they have an active SSE connection to for a client, right? And so we want a way for them to just listen to what matters for them. And so what we can do is that we can partition our PubSub. And so if you're using like Redis PubSub, these are called topics. If you're using Kafka, they're called channels, but they're all the same thing. They're just partitions of our PubSub. You can think of them as just like maybe, kind of multiplying these out. There's not a lot of space here, but you get the picture. Kind of like a stack of different message buses here. And so what you can end up doing is just separating using something like the hash of the video ID, modulo the number of channels that you want or the number of topics that you want. So something like that. And that's how you can determine which one of these it should go on. And then each of these real-time comment services don't need to subscribe to every single topic or every single channel. They only need to subscribe to the subset that they have an active client connected to them with. Right? So you might only subscribe to a couple of these. And this way you're only listening to messages that come in that are either your live video ID or something else that's in this hash grouping. So it's not perfect. It's not like it's only your videos. Someone might be tempted, and I hear this in interviews, they're like, I'm going to partition based on having a topic for each live video ID. This just wouldn't work. It certainly wouldn't work in Kafka. I don't know Redis's limit off the top of my head, but it probably wouldn't work as well. There's limits, reasonable, feasible limits, the number of topics or channels that you have. And so that's why you want to do this hash modulo n thing, so you can just group them together and go from one big channel to n channels, where that n channels might be 1,000, it might be 1,000,000, whatever is needed for scale. That's something that can always be tweaked. But then we're only listening to the ones that matter. Now, the last thing that I'll mention here, and I'm going to go over this just really briefly, is that you don't want to have, let's say that there's 3 people watching video 1. You don't want them like randomly assigned, because then maybe they'll all show up on a different server here. And now 3 different servers need to subscribe to the channel for video 1, when we could put all those on the same server. We could co-locate those. Ideally, you have every single viewer of a single live video on a single real-time comment service. Now, if you have a popular video with 160 million concurrent viewers or something, like the Chewbacca's mom or a World Cup final, then that's not going to work. You're going to need to allocate that over 160 of these. But at least it's 160 and not 500,000, right? So that's one optimization that you can handle. In the case of Zookeeper approach, this actually makes this easier, because when a new request comes in, we're going to look at where everybody else with that video ID is, and we're just going to tell you to connect to that same box. So this is great for that approach. It's a little harder here. The way that this works, and it's a bit complex, so again, not going to go into too much detail, but you can actually have a Zookeeper or another service similar that sits here. And then your API gateway via a Layer 7 load balancer can have in the header what the live video ID is, and then ask this guy, where should I route him? And then route it to the correct one. And so it's similar to the dispatcher approach. We're just only using the dispatcher to do co-location. You could make the argument at that point, then like, why not just come up here and do the dispatcher approach? Like I said, both work, no pros or no right or wrong answer there. It's just a matter of weighing trade-offs. The last thing I'll touch on is that if you're a staff candidate, maybe a fantastic senior candidate, there's more you can talk about here. Like, for example, what is the difference between using Redis or Kafka? You actually probably don't want to use Kafka here because Kafka has a lot of overhead to subscribe and unsubscribe from channels. And you can imagine that when users are scrolling through their feed, they're subscribing and unsubscribing really quickly. If they're not clicking into a live video, they're just scrolling through their feed. And so PubSub with Redis being in memory makes this a lot easier. So maybe it's a better approach there, right? That's the sort of thing that you can talk about to show staff level signal. I guess we should talk about the database. I mentioned that we would come back to that, and I think now is an appropriate time as it pertains to scale. So we said that we would have the 1 million videos. Let's just estimate and say there's about 100 comments per video. I think that's fair. If anything, it's probably even high. The overwhelming majority of videos probably get no comments. This is concurrent. So loosely, let's say each video is about 30 minutes. That's probably too long, but in any case, that would mean that if they were fully sequential, this is like 48 ish, I guess, a day, right? So this is how many we're having a day. It's going to grow quickly. There's a lot of writes here, and this is decent scale, 480 million, right? Is that math wrong? 480 million. I think I'm off by one order of magnitude there. So 4 billion. I don't know. Mental math while you're on the spot in a video for everybody who's watching is difficult, so forgive me. But regardless, I can get a sense here that this is a lot. It's also high write throughput. So we're going to want a database that can support that high write throughput. Realistically, a Postgres database, if sharded and scaled correctly, can do this. SQL databases would work fine. But there are databases that are optimized for this sort of thing. And given that we really have no relations in our data, we probably have a user and a live video ID column. And our query is pretty simple. It's just going to be able to query a primary, or not a primary key, but query an index here for video ID. And then, we can use the created at as our sort key. So Cassandra is going to work well here. It's going to be really easy to shard based on video ID. So we can scale this horizontally. Like I said, sort key on created at. The query is simple. It's just to get it for a given video ID. And it's great at handling the high write throughputs. So that's what I would probably do there. And of course, this is going to result in eventual consistency in places, which is fine. So this goes back to our non-functional requirement of we're going to prioritize availability over eventual consistency. So if we go and we try to read and we have replicas here and we're hitting a read replica or something, it might not have the latest comment that just came in yet. That's okay. We're going to show it to the user anyway without that latest comment. No big deal. And if anything, we have the PubSub or the dispatcher real-time flow to make up for things there. Okay, Let's take a look back. We met our functional requirements. We met our non-functional requirements. We went through the full flow. We nailed the interview. We're hired. We're excited. Hopefully this made sense. The unique things about this interview, just to recap, is when to use WebSocket versus SSE. WebSocket is heavier weight, but necessary for bidirectional communication. We have a one-to-one in the read to writes. SSE is unidirectional, lighter weight, but this means that we can only push from server to client. So it's great when you have a lot more communication in that direction, right? And the balance isn't even there. We talked about how to scale up, whether it's PubSub or a central dispatcher, in order to make sure that we can locate the correct real-time server for which the persistent connection is on. This is a common problem. This is similar to what you're going to do in something like a real-time messaging app, for example. Talked a little bit about scaling databases, the in-memory mapping. I think we've done a good job here. All right, well done if you made it this far. Hopefully everything made sense and you have a pretty good understanding of how to design a live comment feature for Facebook or any other live streaming platform. If you liked the video, give us a like, give us a subscribe. If there were questions, if I did something stupid, wrong, you disagree with, leave a comment. Let's chat about it. I'd love to respond to as many comments as I can. And like I said, keep an eye out. More videos coming to start 2025. But all in all, hope you guys enjoyed and best of luck with your interviews. Talk soon.